Hello everyone and welcome. Today during our virtual class we're going to cover the instructions for making sure that you have pipx poetry and ollama installed, and then after that we're going to go ahead and set up our project. So over here I'm working in a Ubuntu shell, and what we can do is, in order to ensure that pipx was installed, we can just do a pipx version. You should get a version resolved. You can do a poetry version, make sure that that resolves, and then of course you can do an ollama version also to make sure that that resolves. As long as all of those are resolving, we can go ahead and get started. So I'm going to go ahead and make a projects directory for this project. I'm going to go ahead and change directories into that projects directory, and then the very first thing that we're going to do is we're going to kick off and make sure that our poetry environment is set up correctly. So to do that, what we'll do is we'll do a poetry new, and then we're going to call this one as first agent. What that's done is created the first agent directory, so we'll go ahead and go in there. Do an ls, and here that you can see the pyproject.toml exists. The first agent is the directory that all of our code will be in, and then of course tests for testing. Once that's done, we're going to go ahead and start up our poetry environment, and we'll do that by typing in poetry shell. And you can verify that that exists by doing which Python if you're in the Linux environment, and that will show you that we're in our virtual environment now, in our first agent environment. If you're running in Windows, you can do this exact same thing. So we'll go to cd dev, and we're going to go ahead and drop into our projects directory here, and we'll go ahead and do the same thing in PowerShell. And here you see it's gone ahead and created that, and then we're going to drop into that. The commands are fairly similar, except in PowerShell, whenever we want to check to see which environment we're in, so we're going to go ahead and do a poetry shell. You see it's created our virtual environment, and because of the way that I have OhMyPosh or OhMyPowerShell set up, we can see which agent is there. And now I can go ahead and type in the command git command Python, and we can see which Python is being accessed. So again, that's if you're in PowerShell, or if you're on Windows, that should help you. Going back to our Linux environment, we're going to just take a quick look here, and now we're going to start adding in some of the dependencies that we're going to need for our project. So because I'm in my correct environment, right, my first agent Py environment, I'm going to go ahead and do a poetry add. We're going to do a LangChain. Community is our first one. That'll add all of the dependencies for LangChain community. And then we're going to add another one for LangChain ollama. And we're going to add a couple of more that we won't be using today, but we will be using here in the near future, and that's PyPDF. And lastly, ChromaDB. This will take just a minute because of the dependencies for that project. And once those are installed, do an ls, everything should look good here. You'll see a new poetry.lock file. And now we're going to go ahead and just start up Visual Studio Code in this project. Go ahead and bring this over into this recording window for you all to see. And we're going to say, yes, I trust the author, since, you know, I do trust myself. I think I'm an all right person. Now I'm going to go ahead and look in. Here we have agent first init.py, just to show that this is a Python library. And now we're going to go ahead and do a new file and call this one main.py. That's great and dandy. It just sets up the ability for this to exist in terms of a Python project. But we're going to go ahead and take this one step further and actually drop this into a definition now. So over in the pyproject.yaml file, so we're going to drop over here to pyproject. We're going to add a tool here, and we're going to go tool.poetry.script. And what we're going to do here is we're going to just say agent, and we're going to say that equals, in this case, if you look at the file name, the first agent, and colon main. What that does is that actually allows us to just run the command agent after we do our install, and we'll show you exactly how that works. So we'll go ahead and save that. In main.py, we're going to create a, this should be .main in main.py, or main::py. This says what package to look in, which Python script to look in, and then which method to execute. So save that, drop back over here. Now we're going to go ahead and do a def main. And we're just going to go ahead and print hello, just to show you all how this works really quick. So fairly simple and straightforward. We're going to go ahead and open up a terminal. And it's saying my Python extension wasn't installed in this environment, so I'm going to go ahead and install the Python extension. The most recent Python update's pretty great from Visual Studio Code as far as it handling virtual environments, etc. What you see here is when it started the console, it automatically dropped me into my right environment because that is how I started it. So we'll go ahead and close that, and we're going to do a poetry install. And then once we do that, we can just run agent, and you can see here it just printed out hello for us, because agent is the command that we put here, which made it available to us as a running program. So now we'll go ahead and drop that off, and we're going to jump into what it takes to build an agent. And this is actually fairly straightforward as far as building things in Python go. So the first thing that we're going to do is we're going to add a couple of dependencies. One of them is called a LangChain core, and this is just how do we build chatter prompt templates. And the next one is the ollama model, which we'll be using to actually talk to our ollama model instance. From that, we can go ahead and create outside of our definition, we can create a template that's going to drop in the question, and then an answer. Let's think step by step. This is coming directly from the LangChain tutorial for ollama. If you want to look that up, I'll share the links later on. Once we do that, we can actually create a new prompt. And we're going to go ahead and throw this one now into our main, because template's just defined outside of it as more of a static variable. And then once the prompt's there, we're going to go ahead and tell it what our model is going to be. So specifically for this example, we're going to go ahead and do our ollama LLM, and then our model equals, and I believe today we have a llama 3.5. Let me verify that really quick. 3.2. So the latest ollama instance is 3.2. Once that's there, we can create a chain. So this is the fundamental structure of how LangChain works. And it's going to be the prompt and then the model. Now we're going to go ahead and execute that. So we're going to go chain.invoke. And now we're going to pass it a map as an object. Now you notice that up here we have question in parentheses. So what we're going to do is we're going to pass in the question key here. And we'll ask something simple. What is the best programming language? Once that's saved, we can come back down here again, just type clear and hit agent, and it's going to break on me because I'm doing a demo. It says, hey man, you spelled that wrong. So pardon the typo. We'll try this one more time. And agent. And what's happening is now it's actually connecting to Ollama for the first time and trying to invoke what's going on here. Here we don't see any output because I did not print the output. So one moment. And this should be response equals chain.invoke and then print response.content. I'll go ahead and try that again. And it says no to the source string. And here we actually have our answer. So in the response.content scenario, that's actually what we use it in Google Cloud, because this returns, normally the chain invoke returns a map, which has specific parameters. Here in the llama scenario, we only get a textual response that we can see here. So this is very much similar to the way that llama runs from the terminal. But now you can actually start to add more interesting things into your prompt and your template. For example, if you want to add context to your questions, you can do that. And here is kind of a fun example. What we can talk about are the other types of models that we can start to test in this scenario also. So, for example, if you want to do use coding templates to answer code questions, you could do code llama. Additional ones, if you wanted to ask questions specifically around SQL, you could use SQL Coder. And then for a fairly decent general model, there's also CodeStroll, which is a Mistral model derivative specifically for code. So here, if we go ahead and do SQL Coder, and then come over here and say, can you explain and inner join? We'll go ahead and save that. It'll take a minute to download this model because I have not downloaded it here yet. So it's saying, I'm sorry, I don't have that model. And ollama pull and SQL Coder. So with ollama pull, you can pull any model down that you can actually talk to. You do have to execute that because it will take a minute to run. Here you can see that this specific model is another 4.1 gigabytes. That'll take a minute to download. So while that's downloading, just understand that we can specify this And now, in addition to what we're doing here, is we can start to add instructions to our set or additional context. So if we had a SQL database that we wanted to ask questions about, we could dump the SQL structure and then prepend that to the context of the model and ask questions specifically about a given structure. For example, how do I query a name and address from this database most efficiently? And then it can give you that type of response. So as we wrap up here, we're going to go ahead and execute one more time our agent. And now, with the fact that everything's down, you can see first you'll need to create a table, call it inner join table, and it talks about what is actually going on. Kind of helpful, especially for new programmers, but you can see this is exactly what's happening in your IDEs as you're doing code complete or you're talking to ChatGPT or anything else. The only thing that's really happening behind the scenes is it's executing your query plus your code file or your current context against the agent that's behind that specific function. In the case of an IDE, the function just is simply where are you in your IDE and what type of question are you asking? For example, can you add comments to this or can you explain this code? It's actually using that code detected from the cursor in the IDE. Okay, so from here, we have got our very first agent created. This one's a very simple agent as far as what it happens to in terms of the request response. If we wanted to put this into a loop, we could actually come down and define a while loop that helps us, clean this up a little bit, or at least continue to interact with it until we say goodbye or do anything else that we're looking for. So with that, we're going to go ahead and take this specific response out. We're going to comment these out and then come down here, and what we're going to do is we're going to say while true, just go ahead and add a query, and then take the line as input. If we get a break or an end of or exit or quit, then it's going to break also. But here we're going to go prompt and model chain.invoke, and then human message is another thing that we can pull in from the model from LangChain, which tells it what it's looking for. So we're going to come up here, we're going to add a LangChain import for human message and go ahead and save that. We'll come back down here to our terminal and we'll invoke the agent. What is an inner join? And of course it'll break because I'm demoing it, and it broke because I didn't actually put in the correct question. And we'll say what is an outer join. So now what you see is I just had the parameter wrong since I moved this over from an existing project. Once we put that in, then it actually executed against the question. And we can type exit. And at this point in time, we have a ripple, so we can continue to ask it questions, and it's going to continue to build on that chat response. Hopefully, this helps bring into effect of what we wanted to accomplish today. Each of you should accomplish this on your own. Go ahead and take the code that you see in these examples, and from that, build an agent that is effective to what you want it to be. Don't forget, you can add instructions to your agents as you build them out, or instructions to your model to help them be exactly what you want. So if you want it to be a Go programming language expert, you should use the system instruction for that. All of this can be found over at LangChain, which is python.langchain.com, and there's a ton of examples there that will help you just make this model a lot better. But the idea here is as we execute anything, we can work with cloud models. So we could actually change this over to the Google Cloud LLM or even to ChatGPT. Or, of course, we can use local models and then start to build upon this. And this is where our next iteration or next evolution of being developers is going, is by building these custom agents and being able to write intelligent prompts around those and intelligent instruction sets. Then we can create agents that are useful for the business domains that we're working in. Again, I hope you had fun today. I hope this gave you what you were looking for, and we'll see you in class soon. I'm going to put up the next one after this, which will be taking this one step further and then using those other imports that we had, which were a PDF reader, and then using that PDF reader to create a deeper context, and then querying from those PDFs to actually understand the contents. And hopefully that'll be the next fun lesson. Y'all have a great weekend, and we'll see you soon.